All right, let's see if third time's the charm. It's taken me 3 times to get these notes done today, so hopefully I can work it this time. My pen's been acting funny, so hopefully we'll go with it this time. These are notes from Wednesday, September the 29th, Thursday, September the 30th, and these are notes over section 4.3, which is writing functions. So basically we started out, I've actually filled in a few sections of these notes just to allow them to go a little bit quicker, so if you're just using this for the purposes of copying the definitions down, you can silence the notes if you need to and just copy down the definitions. If you're using these tutorials for a reteach, I'm going to go through not all but several of the written down parts, and then on the back page I'll go through all the examples with you. First of all, independent and dependent variable, which we've gone over before, but we formally defined on Wednesday. The input is the X part of the sentence, or the independent variable is the input, which is the X part of the sentence. The dependent variable is the output, or the Y part of the sentence. So what you're going to do with these two ideas is create depends statements out of math sentences, identifying the independent and dependent variables. Okay, let's see. Okay, now we're working. Let's see if it'll go. So basically what you're going to do each time you read a sentence is identify the independent and dependent variable, and then once you do those, you can create a depend statement. When we took notes initially for this chapter, for this unit, we gave kind of some hint notes, and the hint notes that we used for this section was Y depends on X. Sorry about my handwriting. It's worse than normal. For some reason the pen's not working not properly, but this is better than what it was doing. So Y depends on X, and so when you write a depend statement, that's kind of what you're looking for, is to look for the Y part of the sentence, which is the dependent variable, and the X, which is the independent. So our first sentence: an employee who works longer hours will receive a larger amount on her paycheck. The independent idea in this problem are the number of hours, and the dependent is the amount of the paycheck. So to write your depend statement, since Y depends on X, you would write the amount of the paycheck depends on the number of hours. Each time you read a sentence, you should be able to figure out kind of two things. One is the independent variable, which is the part that changes. That's the variating part, so to speak, the number of hours or the number of months or whatever problem you're doing. And then the total part is usually the dependent variable. That's the output, or the Y. A math tutor charges $35 per hour, so the independent is the number of hours. The dependent is how much the tutor gets paid. So the depend statement, the money a tutor is paid, depends on the number of hours worked. And likewise, our fitness center problem, that they charge a $100 initial fee plus $40 per month. We need to know the number of months to determine how much we're going to pay. So our depend statement will be the amount you paid depends on the number of hours, or number of months, sorry, you worked out in the gym. And continuing on, the fire was very large, so many firefighters were there. You need to know how big the fire is to determine the number of firefighters needed. So our depend statement would be the number of firefighters needed depends on how large the fire is. Likewise, we have our temperature problem and our restaurant bill problem. Each of these, you would identify the independent and the dependent variable, and then create your depend statement, always remembering that Y depends on X. So on each one of these, your X and Y are your independent and dependent, and when you make your depend statement, make sure you write it what I like to call backwards, basically. Your Y depends on X. So the total part will be first. For example, in the restaurant bill problem, it says the amount of the bill depends on the number of meals ordered, and I obviously didn't finish that sentence. But that should be like this: the number of meals ordered. But that would be your independent and dependent variables put together in a depend statement. So then we take the idea of independent and dependent and we start hooking it into our domain and range. Independent is the X, domain is the X, dependent is your Y, and your range is your Y. So if you think of this from a mathematical sense, you can take an equation, for example this one right here. The function rule is 2x plus 3. Now we can write that Y equals 2x plus 3, or we can write f of x equals 2x plus 3. F of x is just a fancy way of writing Y, so you'll see that used interchangeably throughout the assignments and the notes that we'll do. So let's say we have a function rule, y equals 2x plus 3. You would go to the y equals screen on your calculator and type that function in. On y equals, you would type in 2x plus 3. And then to see the values for your domain and range, you would press second table or second graph. Table is the feature that gives you your values, although you can take each one of the domain values and plug it in for X to get the range values, which are your Y. It is very easy to do these by hand. We create a more efficient atmosphere when we do them on the calculator, so that's why we usually go to the calculator so that we can be a little bit more efficient in class while we're working. Each one of these values, if you plug it in one at a time, if you plug in the -1 in for the X, you'll get an answer of 1. If you plug in the 0, you'll get a 3. If you put in the 1, you get a 5. And if you plug in the 2, you get a 7. So that's our range. Those were all yielded from the domain -1, 0, 1, and 2. And if we created ordered pairs out of those, -1 would go with 1, 0 would go with 3, 1 would go with 5, and 2 would go with 7. So you see the idea of domain and range being put together, independent and dependent, all being the X and the Y values, and you can generate answers through the table feature on your calculator. So moving on, now we're going to do the same thing again. It was just a little bit more practice in class that we did, typing in on the calculator to make sure that you're comfortable getting your domain and range. All of these can be worked out by hand if needed, and so this time I'm going to write down what you would do by hand if you wanted to work it out that way. So our domain is given here, -4, -1, 2, and 6, and your function f of x equals -2x minus 4. Basically, I'm going to take the x out, and in its place, I'm going to put the domains. -2 times -4 minus 4, -2 times -1 minus 4, -2 times 2 minus 4, and -2 times 6 minus 4. And if I do the math on all of these, either in my head or the calculator, my answers would be 4, because -2 times -4 is 8, 8 minus 4 is 4. The next one would be, let's see, -2. Then you would have -8. And finally, you would have -16. And those can all be checked on the calculator if you prefer to do them by hand. Now I had a little typo right here. This should actually be 2x to the second power minus 1. So basically what this wants to do is just show you that sometimes your function notation might be written with a different letter, like f of x, g of x. It's all the same thing. It really just means y equals. When you're dealing with more than one function, they usually use a different letter to differentiate between the two. So if I need to calculate f of -2, that means I want to take the -2 and plug it in for the x in the f function. So 2 minus 3 times -2 would give us 8, because 2 minus 3 times -2. -3 times -2 is 6, and 6 plus 2 would be 8. G of 5, if I've got 2x squared, so I'm going to have 2 and then times 5 to the second power, subtract 1. 5 to the second is 25, times 2 is 50, minus 1 would be 49, all of which can be found on the table on your calculator. Now in this one they're asking us to evaluate two different functions. So if I do f of 4, I would have 2 minus 3 times 4, which would be -10. If I do g of -1, I would have 2 times -1 squared minus 1. -1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So -10 plus 1 is -9. So sometimes you can evaluate multiple functions at one time, all of which are just practicing multiplying, dividing, adding, and subtracting integers, and the kids should be really familiar with that from previous years. Finally, we put all our ideas into one problem. We're basically taking the idea of worded problems, creating an independent and dependent variable, coming up with what the function rule would be. This is really the first time the students have created a function rule on their own, although they've been translating equations for quite some time, and then actually evaluating for different values. A zoo charges $6 for parking and $17.50 for each child. So the way that I would figure out my total cost would depend on the number of kids that I would be taking. So the number of children would be my independent variable, and then the total cost would be my dependent variable, because the total cost depends on the number of children taken. Now the function rule for this problem, I know I'm going to have to pay $6 to park the car, but I'm also going to have to pay $17.50 for each child I take. So our function rule, f of x, or you could put y equals, would be $6 for parking plus 1750 per child. You can write 1750x plus 6 if you prefer. The order doesn't really matter necessarily. So now each time for the x, you're going to plug in a new value. We want to know how much it would cost to take four children or 10 children perhaps. So I believe the answer for this one was $76. And the answer for this one was $181. Each time you plug in the value, you can come up with the total cost. This is very, very usable, obviously, in real life. Different scenarios that might occur, and you're trying to figure out how much money you have. Is that going to be enough to pay for what you need? But this is how the students will use all the ideas together of domain, range, independent, dependent, and being able to write the function rule and evaluate different functions.